Hello there, here's Mr. Hotard. This is just quick notes on factoring higher order polynomials in case you missed it in class today. Alright, first of all, when you're factoring, just like before, you always want to look for greatest common factor, GCF, something you could divide out of the whole problem. You always look for that first. It can be a number, it could be a variable, it could be a number and a variable, it could be a variable with an exponent, just something you can divide out of the whole problem. And then you look for how many terms there are. So if there are two terms, you want to try to do a difference of squares. So some of this is a review of things we've done before. So for example, x squared minus 16, we've done that one before. Remember, the middle number is just 0 there. So numbers that multiply to give me negative 16 add to give me 0. That's x plus 4, x minus 4. That one's easy. All right, now, this one, before you try to split it up, is there a GCF? Yeah, you could divide it all by what? 3x squared. They all have exponents, so go with the smallest exponent. GCF is 3x squared. Going to leave me with x squared minus 25, and then I can factor that some more. 3x squared is GCF. I could split that up into x plus 5, x minus 5. Now this third example, 16x squared minus 9, I'm going to factor it just like these. I'll have x plus 3, x minus 3, but what would I need on both of these x's so that they multiply to give me 16x squared? I need 4's. 4x plus 3, 4x minus 3. Now something new we haven't really done before, 4x to the 6 minus 25 if you have something besides x squared. There's no GCF here. I'm going to solve it similarly to this. All right, I have, just like that one, would be like 2x plus 5, 2x minus 5, but that's not exactly right, because 2x times 2x wouldn't multiply to give me 4x to the 6th. That would give me 4x squared. What would I need on both of these x's? I need x to the thirds. 2x to the third and 2x to the third would multiply to give me 4x to the 6th. All right, that's when you have two terms. Now, if you have three terms, remember, three terms, you're just looking for numbers that multiply to give you the back number, add to give you the middle number. So that would be x, bigger number got to be negative this time. So x minus 8, x plus 2. Now underneath that, is there a GCF here? Yeah, you can divide it all by what? By 3. So divide out the 3 first, leaves me with x squared plus 2x minus 15. Now what numbers multiply to give me negative 15 add to give me 2? 5 and 3, which one's going to be negative? The bigger number got to be positive, so it would be 3x plus 5, x minus 3. Those would be my factors. Now, something like this example, if I have a number in front of x squared and I can't just divide that number out of everything, all right, there's a couple ways of doing it. I think the easiest way is the rainbow method. If you do 2 times negative 15, that's negative 30. So numbers that multiply to give me negative 30 and add to give me 7. Let's see, that can be 3 and 10. Bigger number got to be positive, so x plus 10, x minus 3. But that's not the final answer. Remember, last step for rainbow method, divide by whatever's in front of x squared. Divide by that 2. So that's going to be x plus 5, and can't reduce that, can't divide it, so move the 2 in front. 2x minus 3. Those would be my factors. Now over here, this one right here, there is no number in front of the u. So I'm just going to factor it similar to this, except since it's u to the 4th, instead of putting u and u in parentheses, what would I need on those u's? U squared. So numbers that multiply to give me negative 15 and add to give me negative 2, going to be negative 5, positive 3. So u squared minus 5, u squared plus 3. Got to have squares so that they multiply to give me u to the 4th. And then nothing more I can do with that. None of these are perfect squares, so I can't split that up anymore. Now, last type of factoring. If I have 4 terms, we looked at 2 terms, we looked at 3 terms. What if there are 4 terms? Then I want to try to use something called grouping. So if you look at this first example, is there a GCF for the whole problem? No, there is not. So I'm going to split it up into 2 groups. I'm just going to put parentheses and find the GCF of each group. All right, so my first group right here, what's the GCF here? If you just look at these 2 terms. 3 what? 3n squared. So that's going to leave me with n plus 7. Now, what's the GCF of the second group? Just 8. I'm going to put a plus 8, and then what's left when I divide out 8? It'll be n plus 7. So now, since they both have an n plus 7 in parentheses, I can move that parentheses to the front. N plus 7, just factoring that out. And then what will be left after I move the n plus 7s to the front? I'd have 3n squared and plus 8. These would be my factors. All right, 2 more quick problems. Underneath that one, again, looking at this whole problem, there is no GCF. I have 4 terms, so let's group them. What's the GCF of the first group? Z squared. Gonna leave me with z plus 5. What's the greatest common factor of the second group? Not just 4, it's negative 4. So minus 4, and when I divide that out, gonna be z what? Plus 5. Negative 20 divided by negative 4. Again, in order for this to work, you'd have to have the same thing in both sets of parentheses. All right, if you get into 2 different things in the parentheses, then either A, you made a mistake, or B, you just can't factor it by grouping. All right, but this one, it worked. So I'm gonna pull z plus 5 to the front, gonna leave me with z squared minus 4. Now that is correct, but it is not finished because you can factor z squared minus 4. That's a difference of squares, just like these up here. So this final answer is going to be z plus 5, z plus 2, z minus 2. Oops, minus 2. Those would be my factors. And last problem. Again, 4 terms, so I'm going to use grouping, but remember, look for GCF first. Is there a GCF for the whole problem? 3x. I can divide the whole problem by 3x. So that's going to leave me with x to the 3rd plus, this would be 3x squared minus 4x minus, what is that? That's 12. So I did GCF. Just divide that out of the whole thing. Now, don't worry about that 3x anymore. I'll need to bring it down as part of the answer, but just use grouping on what's left. Group these 2, group these 2. So 3x, that's just a 3x GCF. What's the GCF of this first group? X squared. Divide that out. I'm left with x plus 3. That's an x. And then what's the GCF of the last group? Negative 4. Divide that out. Got x plus 3. So now I have the same thing in both parentheses, so let's just pull that to the front. I still have my 3x GCF. I'll have x plus 3. And what's left in the problem when I divide it out? X squared minus 4. Now, is that a difference of squares? Is that a perfect square? Yes, it is. So I can split this one up some more into x plus 2x minus 2. So final answer, all the factors would be 3x, x plus 3, x plus 2, and x minus 2. All right. I hope that makes sense. This is Mr. Hotard signing out.